All right, let's solve problem 2 now. All right, we're working on the practice problems for formatted I/O. So number 2 says we want to write a C statement that calls printf to perform the following actions. So what I'm going to do is I'm just going to copy this out of the Word document. And all right, I already have this code blocks project up from solving exercise 1. I'm going to make a new file now for exercise 2. I'm going to say file, new, file, new, file. All right, I want a C source file. All right, next, I'm going to click on the dots here so it has the path. Exercise 02, it'll save it with a .c extension. Just want to make sure it's in the debug release. All right. So I like to copy what we're being asked to do, the problem statement in here. All right. Pound include standard io.h because we're going to use printf. All right, we're writing a separate C program to do this. I need the return 0 statement because my return data type of this function is an integer, so I need to return some sort of integer value at the end. We use 0 by convention. All right, so first what I want to do is I want to display a float variable x with 1 digit after the decimal point. All right, that's task A. So a float variable x, display a float variable x. I better declare a float variable named x. So remember, when I declare a variable, I have to use its data type, in this case it's float, and give it a name x. All right. Now, whenever I declare something, it has garbage in it unless I assign something to it. So let's just go ahead and make this 0.1, 2, 3, 4, 5, 6, 7, 8, 9. And now if I want to display it, well, I'm going to use printf, formatted output, %f for a float, and that uses 6 decimal points by default. So if I say 0.1, that gives me 1 decimal point, and I want to display what's in x. So this is going to go to the memory associated with x, get its value, and then substitute that value in here, but only show us 1 decimal point. All right, so let's just go ahead. Right now, if I were to compile this, it should compile. All right, no typos. What happens if I say build? I want you to pay attention to the fact that I now have 2 files in this project, and they both have a main function. When I build a project, I can only have 1 file that has a main project. For instance, if I say build now, we get this error message down here. Multiple definition of main, first declared here. So what I want to do is I want to remove exercise 1 from the project. So I'm going to go here, I'm going to right click and say remove file from project. Now that doesn't delete my file, it just takes it out of the program environment. So I haven't lost my work. Right now, I should be able to say build and run, and I won't get that error. Right, so when this pops up, right, we get 0.1. We just get 1 decimal point. Right, that's what we were asked to do. And let's just go ahead then. We want 7 decimal points. I just put a new line character in there. All right, let's just go ahead and show A, B, and C. So if I want 7, right, we're going to say %7f. I'm going to put the new line character in there as well. We'll just say display what's in x. And let's show both of them on the screen so we can compare that. So we'll build and run. And we get 0.1, 2, 3, 4, 5, 6. And notice in this case, instead of 7, it rounded it up to 8 for us. Like I said, the rules of floating point, you can't always guarantee that that will round up. It's because of the way floating point data is interpreted. But in this case, it did round up for us. All right. now we want to display an integer variable x, right justified in a field width of size 10. Meaning, I'm going to need to declare an int named x. Copy this, put this in as a comment, but I can't say int x here. If I do that, I have two variables named x declared here. What happens if I just compile? Right? Error, conflicting types for x, previous definition of x was here. So I can't use x in both cases. If I wanted to, I could go ahead and make this y, or I could comment out this section up here. So if I comment out this section up here, right, I don't lose my work in case I want to uncomment and see it. But if I want to use x again, now I can do this. All right, and now we need to give x some sort of value. All right, so field width and size 10. Wait. So now, let me just give this the value 1, 2, 3, 4. All right, so we'll know what we're going to display. And printf, well, %d. If I just use %d and say x, it's going to give me a field width of 4. All right, give me the new line character. The field width of 4 is based on the actual width of my integer, which is 4 digits wide. All right, but now, if I want 10, by default, it right justifies. So I just put the 10 in here. %10d, 10 is my field width. All right. Oh, now then, we got our 4 characters with 6 blank spaces to the left. Right. Now, how do we left justify? Right? So we still want this to be 10 wide. But now we need to put another specifier in here. And one of my favorite sites, if I forget to do how to do something, is to go to C++.com. And now, if under search, if I type printf, it brings up this nice table of all the different specifiers we can use and all the different flags we can use. So notice the justification specifier is a flag. It's a negative sign. That says left justify within the given field width. Right justification is the default. Right. It talks about the width specifier down here. But what we need to do is we need to add this negative sign in front of here. So right here, that doesn't mean we're going to have a negative number. That means left justify. So let's build and run now. Print them both out to compare them. So by adding that negative sign to the left, we've managed to left justify. So these are just ways to help you when you need to print out tables, columns of data to line everything up nicely. All right, so that was exercise number 2. Experiment with some of these different ones.